Now I have Walter Rumsby to talk about observability for JavaScript developers. Welcome.
Hello there. This is my opening slide. My Twitter handle is @wrumsby. I've just tweeted a copy of these slides there if you wanted to look at them in the future. So today I want to talk about observability for JavaScript developers, and how that's going to break down is basically defining what observability means, why you should care, some examples of using observability software, and then a little bit of information on where to find out more. So, starting with the definition, this is the canonical definition. This actually comes from control theory. So it says that you can measure the internal states of a system by examining its outputs. Because we work in an industry that is, I guess, very buzzword heavy, the definitions sort of blur. Different people define things in different ways. I think this is actually a pretty useful definition. That definition comes from Honeycomb. They're, one of the leading observability tool providers. So observability allows you to answer arbitrary questions about your distributed system. And I've underlined both of those words because they're sort of keywords in this message. Oh, sorry, let's go back to that. So arbitrary is important because you want to be able to answer questions that you haven't anticipated. Maybe you have experience using APM tools, and they're like, here's your node memory use, here's your CPU utilization. That's sort of core monitoring kind of from the traditional world of ops. Observability sort of gives you the ability to sort of layer on insights that are domain specific to your context, so that you can say, what's happening with this class of customer? What's happening for users in New Zealand? Questions like that. Distributed is the other keyword here, and that is important because as your systems become more complicated, your need to understand them becomes more sophisticated. And an observability tool or a tool that supports distributed tracing will let you see calls across services and sort of understand end-to-end what's going on in your application, what the experience for your users is across a number of services. So in both cases, we're going to drill down into a bit to say, here's an example of arbitrary, here's an example of distributed. So, kind of, in a way, in terms of what I'm going to be able to cover, this is probably the message that I want to share the most. And it's about why you should care about observability. Imagine you have, in your organization, this is how teams are structured. I'm using team topologies style stencils of how teams are organized. And what you have is you have a number of development teams that are stream-aligned teams, and you have an operations team that sort of fits closest to the idea of a platform team. So basically, what you would do is you work in your team. When you're ready to go live, you say, hello, operations friends, here's the code. When they're ready, they'll deploy it to production, and then they'll monitor it, and they'll deal with any uptime issues. Which sounds great, doesn't it? If we look at the definitions of these team types, I think it's important to sort of drill down into this a bit and say, the stream-aligned team or the development team, they're about focusing on a part of the business domain. And a platform team, I mean, there's some words there, but basically what they're trying to say, they exist for the reason that they should be helping accelerate delivery by those other teams. So in this, let's see, in this scenario, who knows most about what's going on for the users of your software? It ends up being the operations team. This means that you and your teammates are potentially disconnected from the actual user experience of your users. They don't know what frustrations they might be suffering. They might not know exactly what the operations team are doing to keep your software running. You might think it's all great, and they're doing literally crazy things. If you say use Postgres, where would it be? Where was the right place to put the person who knows the most about Postgres in that situation? You could say in the operations team, right? Because they have to deal with the messy reality of running the software. The issue there is potentially you don't have the level of knowledge and experience to avoid handing something to them that requires them to sort of plug a lot of gaps. If that knowledge was in your team, maybe like the overall work in the system to make sure things ran well was reduced. The other thing is if you have a platform team that's serving multiple development teams, they might say, we know SQL Server, you have to use SQL Server. And that affects how your teams are able to operate, how your teams are able to hire. Maybe a relational database is not at all appropriate for the problem you're trying to solve. The other thing is if they're serving multiple teams, when you say, here we go, this is ready, they might say, we're not ready. So that hasn't actually helped accelerate delivery. All of these handovers and so on are unintentionally slowing things down. Now, I'm not saying this to hate on operations people at all. That's a stressful job with lots of people going, help us deploy our software, make sure it runs, stay up all night, here goes the pages, you deal with the problems. But I think what has happened is that there's some unintended consequences in that sort of traditional model of delivering software. And I would even say that as sort of technology and practices have evolved, that solution that maybe was the best thing to do 10 years or 20 years ago no longer needs to be the best solution. Secretly, this talk is about DevOps. And this is actually what I think DevOps is about. People are like, oh, DevOps are Kubernetes, write some bash scripts, I'm using TeamCity, look at me go. DevOps is about bringing developers closer to customers, and it does that by saying, well, let's bring developers closer to operations. Turns out operations are the people who are closest to the customers, so now the developers are suddenly like, oh, you're having a terrible time. I'm sorry, I'll fix that. Let's see. Yes. Now, this diagram here, this is actually, it's interesting. If you search for DevOps image, you get all sorts of this sort of infinity symbol images, different variations. There's like a logo here, which is sort of based on that too. But I kind of what this basically highlights is operations was responsible for release, configure, monitoring, and planning for all the operational concerns. Development was responsible for creating, verifying, packaging the software, and planning for all the software development concerns. Now where you have a software team that is operating following DevOps principles, that basically means the development team is now additionally responsible for releasing, configuring, monitoring, and thinking about operational concerns in their planning. Change can be pretty scary. Again, from the sort of team topologies idea, one model that can work is you have a DevOps team, and this sort of purple kind of looks like a Band-Aid almost, color of team or sort of stencil of team is basically what's called as an enabling team. So it doesn't mean that a DevOps team is the end result. The DevOps team is the journey of helping the developers and the development teams understand operations, understand tooling, and so on. And the idea would be probably the DevOps team here helps all these teams understand these new responsibilities, and then eventually the operations people would sort of go into the development teams and help drive that going forward. Let's see. DevOps team, cool. Okay, so just to kind of underscore why we're doing this, the reason is that that basically we actually believe that this would result in better software, software getting to people faster, and there is research that backs that up. So basically, here, that's the quote. A DevOps approach believes that developers will deliver better software when they better understand how their customers actually experience their software. Now, if you're talking about observability, you're going to hear the name Charity Majors, or she is going to come in front of your, whatever your feeds are and so on. And this is actually a slide from, I think, Monitorama 2017. I'm not sure if you can see that little line there, but she says, you should get used to, and I think she's talking about software developers, should get used to observing your systems when they aren't on fire. Sometimes you look at the dashboards and the error reporting tools because there's a problem. If you actually look at it when it's operating as it's supposed to, you could maybe notice that there are problems happening. And kind of backing that up, she and a couple of other people from Honeycomb run a podcast called Ollycast, and she sort of recently said, I think last year in an episode she said, I don't believe that you could be a senior engineer until you've spent enough time in production. Otherwise, I don't care how many data structures and algorithms you know, your intuition will have been trained on something that isn't real, and that means I can't trust it. Now, I've taken this slightly out of context, so it's a little bit more hot takey and a little bit more sounds controversial. But I think in context, I agree with what she's saying. And that's effectively, you can do a lot of planning, you can do a lot of anticipation about how you think the software will be used. How users use the software can turn out to be different. How your multiple systems interact with each other can be different from what you imagined. Her advice is basically, you deploy, and then the next thing you do is you don't go and pick up the next Jira ticket or whatever. You go and look at the system in production, in your tools, and go, that looks right, that looks wrong, that's interesting. I didn't think about that. Now, I think for me also, this goes back to happier times when this is the best piece of code I've ever written. This is the only bug-free code I've ever written. And I was like 8 or 9 years old. And the thing that was amazing about, having these 8-bit computers and writing terrible programs like this is you got immediate feedback. And I think actually that's why a lot of my career has actually been in UI, because you get immediate feedback. You're like, well, we'll just try changing this, refresh the page. Oh, that's better. Oh, that's worse. Oh, something terrible happened. There's a real addictive quality to that feedback loop. And I think kind of what Charity Majors is saying is, for your non-visual code, for your server code, you can also get that feedback by rolling that code out into production, observing it, using tools that let you see what's going on. Basically, observability tightens the feedback loop. Now, before I sort of get into some examples of using software, there's kind of one last point that I wanted to highlight, and there's been a couple of talks over the conference that have said sort of similar things, or things that I felt resonated and were in the same sort of theme. A couple of weeks ago, I heard about this 2014 study, and it talked about effective teams. And the finding in this study was that teams where people felt like everybody listened to each other were the most effective teams. So it wasn't number of meetings, it wasn't remote, in person, having 6 monitors, whatever it was like, when I talk, I'm heard. When my coworkers talk, we listen to each other. And I kind of want to maybe take a little bit of liberty with that and say, perhaps more broadly, that when teams are aware of what's going on, they're more effective. Sarah, your quote was about blameless postmortems, and you said, trust that people make the right decisions for the information they had. And I think what I underlined there was like for the information they had, because it's not that people are bad, but people might make bad or poor decisions because they're not completely aware of all of the context. So ideally, these tools help you see more of what's going on. How are we going for time, James? Cool. All right. Okay. So that's kind of that's the how part, and that's kind of or the why part, right? And I really want you to think about those things. So now a little bit into the how. I'm going to use New Relic as an example, not because it's the best tool or whatever, it's the one I'm most familiar with. I'm wearing these beautiful New Relic socks, but yesterday I was wearing some wonderful Raygun socks, and I think socks are the best swag there is. So, pretty much, you know, one of the great things about JavaScript is the kind of breadth of the ecosystem, and it generally means that a vendor is going to provide tooling for the JavaScript ecosystem. So, you know, typically you'll go to NPM and you'll get some installation instructions, and this is how you set up your agent. And if you did this and you plugged it into your Express app, you'd get all this monitoring about, oh, here's, you know, requests that are happening, here are errors, here's, you know, performance, CPU, information like that. New Relic also has Lambda monitoring, which is nice. So you plug that in and you get this, you know, and this is very, very high level, scratching the surface. You get the summary of what's going on with your Lambda function. But I recommend whatever tool you use, have a look in the API documentation for the word custom, because custom is where all the interesting stuff happens. So that's the node agent. I think they said like 32 references. And, you know, looking at that, so as a kind of summary of what's in that page, it's like there's custom instrumentation, custom transactions, metrics, events, and attributes. So again, a lot of these tools, like maybe there'll be a standard Postgres instrumentation or a standard MongoDB instrumentation. You might do some custom instrumentation if you're using a tool or like a database that isn't instrumented. Follow their API, figure out how to send data back to New Relic. So it's like, oh, hey, you're calling a database, and this is how many database calls you're making. So, you know, those things exist. I think for most people, most of the time, they're quite low level, but it's the custom events and the custom attributes that are the really interesting things. So, actually, going back to Charity Majors, she talks about this concept of cardinality, which is sort of funny because I think she's recently sort of come to realize that when she talks about cardinality, no one really knows what she's talking about. But she says it matters for observability because high cardinality information is the most useful data for debugging or understanding a system. So high cardinality means, you know, it's basically relatively, you know, it has a high degree of uniqueness, right? So user IDs, shopping cart IDs, stuff like that. Effectively, custom attributes, or at least in New Relic's language, are these sorts of bits of custom information about your domain, and you can say, oh, I can add a custom attribute, and now I can see everything that this user is doing. And, you know, or this is this account number, things like countries, maybe I think actually they were mentioning on the most recent version of their podcast, maybe API keys. Perhaps you know, somebody who's using your API is doing something crazy, so maybe your overall health looks fine, but there's one particular user or one particular group of users who's doing something that's a little bit oddball. And if you understand that, that might highlight there's a bigger problem that if other people do it, things might start to fall over. So, I mean, one of the things I actually do like about New Relic is it has its own query language. and, and you can, and they have all these different sort of entity types, and you can run queries like this where you're like, okay, tell me about all the Lambda invocations from, this set of Lambda functions, with this name, where this is the user ID. So maybe I've rolled something out and I'm testing it myself and that's my user ID, and I've been doing it over the last 3 hours, and I'm like, okay, all of the performance looks good, or, there's nothing unusual here, or there are some things I didn't anticipate. There's actually this other nice little feature where, if you do use New Relic and you don't know about this, there's a column which is custom attribute keys, which will tell you what all the custom attributes being captured by your coder. So, yeah. And, the other nice thing about NRQL, their query language, is you can build dashboards, you can trigger alerts, and so on. The other part of our definition, arbitrary, okay, cool, perfect, was distributed. So distributed is, basically multiple services, or, it can even actually just be browser analytics to server analytics. And so, really basic example of this, which is from production 2 weeks ago, sadly, is this. Does anything look bad to you? Every time I look at this, this number seems to go up, and I'm sure it's the same screenshot. There's 64 spans. There's a lot of calls to the database. There's this beautiful waterfall. The time isn't that bad, actually. But sometimes the time is bad. Oh, I was going to do this bit, wasn't I? I'm going to go down the back. I don't know if you can see this. If you can't, I have a really good optometrist I can recommend. I can't even see it. There's a tiny, tiny blue dot right at the top here in terms of execution time. So yeah, people up the front, you got the good seats. It's just here. Most of the time, that 100 millisecond time it's running. And just luckily for us, this invocation that took 26 seconds or so, whatever, turned up, and because nothing else had happened, we got an alert saying, in the last 5 minutes, all of your API calls have been taking 25 seconds, and your API times out after 30 seconds, so that's probably a bad thing. It was because of this. And by being made aware of this, we were able to change that into this, which is much nicer. It means, that's about half as long. We're using DynamoDB a lot less. We're very serverless, so we only pay for usage. So if we can reduce usage, that's great. That means there are no other ongoing effects for users from this. So, it's a bit sad that we had to be alerted to find this. It would be nicer if when we deployed this code, we looked at it and fixed it, but also this is 4-year-old code, so it's been running terribly for 4 years. Those poor customers. Distributed tracing gets, this is a little bit more distributed here, where we've got a service calling other services, and then they have these different colors that show, so you might see, this actually, this is a small detail. That's taking a while, and that's showing it's anomalous. These aren't so bad. These boxes here, these sort of lines here sort of indicate, well, maybe that's a cold start, or maybe that's DNS resolution, or maybe that's receiving the request, or on the other side, getting the response. But, these tools, once you get used to looking at them, you start to see things and go, that doesn't look right. That's not right. We can fix that. Now, things to look out for. What are they? Oh, yeah. Depending on the tools, you might have quotas, the number of attributes you can capture, the number of things you can send to the endpoint, reserved words. Account ID is a reserved word for New Relic. So, when you query account ID, it's going to tell you what your New Relic customer account is, not the account of your customer's account. Some solutions that aren't instrumented. So that might actually influence your choices of technology. And that might, push you back towards more mainstream solutions. What was I going to say? Basically, in conclusion, in my perspective, a DevOps mindset is about development teams being responsible for building and running software. And I think that leads to better software, better user experiences. And if you're going to take on that additional responsibility, though, you also need to use good tools to support you in that work. More info. Mipsy Tipsy is Charity Major's Twitter handle. She hosts a podcast called Ollycast. There's supposed to be an L there, sorry. OpenTelemetry is an emerging open standard that multiple vendors support. It's, I think currently all the vendor-specific stuff is a bit better, a bit more mature. Team topologies I mentioned. Accelerate has all the research about jobs. We are hiring. And that's time. I'll just hang that up. Yeah.